Today's lesson is lesson 4.3 on triangle inequalities. Now try this out for a moment. Get yourself a straight edge and a compass and try and construct a triangle given these three side lengths. Side length AB being 1 inch, BC being 2 inches, and length AC being 4 inches. What happens? Well, like constructing any triangle, start by just taking your compass, measuring out the length of AB, bringing it down on a segment AC there, and drawing an arc. Then with the same compass, just go ahead and measure out length BC, move that over and pivot it on point C on your third segment, draw an arc. Notice we can't make a point of intersection between these two arcs because length AB and BC are so short that it's impossible to find a point of intersection to make the third point in a triangle. This leads us to the triangle inequality conjecture, which says that the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So for example, in this triangle we have a length of 2 inches, a second length that's 3 inches, and a third length that's 4 inches. Following this conjecture, if we add any two side lengths, it's going to be greater than the third length. 2 plus 3 is greater than 4, 2 plus 4 is greater than 3, 3 plus 4 is greater than 2. All of these combinations check out fine. But on the other hand, let's say that we try to make a triangle where one side was 2 inches, a second side was 3 inches, and a third side was 5 inches. Again, following the definition of the conjecture, you'll see that while we can certainly add two pairs of numbers together that are greater than the third length, 2 plus 3, the shortest two lengths added together, only equals 5. It's not greater than 5. And as a result, the point of intersection between those two side lengths will actually be on the third segment, not above or below. Triangle side angle relations. Now let's say that we're given the triangle ABC. What's the longest side that appears in length ABC? Well, length CB is the longest side by appearance, at least as long as we judge by appearance. Now, what's the largest angle, again judging by appearance? You'll notice when comparing those three angles that clearly the angle that's largest there is angle A. Now ask yourself this question. How do these two relate to each other? What's the relationship between the longest side length in the triangle and the largest angle in the triangle? Well, you'll notice that the largest angle and largest side are opposite each other. On the other hand, what about the smallest side and the smallest angle? Again, judging by appearance, you'll notice that the smallest side length is AC and the smallest angle there appears to be angle B. And again, what do you notice about these two? How do they relate? Just like in the previous example, the smallest angle is shortest the smallest side. So, this leads us to the side angle inequality conjecture, which says that when we're given a triangle, if one side is longer than the other side, then the angle opposite the longer side must be larger than the angle opposite the shorter side. So for example, if the measure of angle A is greater than the measure of angle B, then it can be concluded that the length of BC is longer than the length of AC. Now there's one more conjecture in regards to angle sums in a triangle, and it's called the triangle exterior angle conjecture. The measure of an exterior angle of a triangle. Now an exterior angle is where you extend any one side beyond a vertex, and the angle formed between that side and the next side of the triangle is considered the exterior angle of a triangle. Now the measure of an exterior angle of a triangle, and this qualifies for any exterior angle, is equal to the sum of the measures of the remote interior angles. Now, since we haven't had that vocabulary word yet either, understand that the remote interior angles are the angles opposite the exterior angle inside the triangle. So again, the measure of any exterior angle in the triangle is equal to the sum of the measures of the remote interior angles. So for example, if these two remote interior angles were 100 degrees and 30 degrees, then the measure of the exterior angle must be 130 degrees. Thus concludes today's lesson.